Hi everybody, today we're going to talk about how to describe the domain and range of different graphs. So I want to remind you that the domain is the set of all inputs, which are our x values. So we're describing all of the x values that we see in our graph. And the range is the set of all outputs, which are the y values. So we're going to find a way to describe all of the y values that we see from our graph. Okay, so for this first example, you can see our graph here. We're going to describe the domain and range using both interval and the inequality notation. So let's start with domain. So remember, domain is all of the x values. So what I'm going to do is I'm going to find where my graph starts, or where the farthest left point is and where the farthest right point is, and I'm going to highlight that in blue. So I can see that my graph goes from here to here. So remember, we're doing the x values first because it's domain. So let's start with interval notation. So remember, we always start with our farthest, our smallest number, our farthest to the left number. So I see that this number occurs at -1, 2, 3, -4. And since this dot is included, it's a closed dot, I'm going to do a bracket. Brackets mean the point is included. And then all I need to do is find the farthest number to the right, our largest number. And this number is +4, and since it's a dot, it is also included. And it looks like this. Now if I were to rewrite this with inequalities, we do -4, +4 with x right in the middle, and we then do our less than or equal to signs because the points are included. Now for range, remember range is all of the y values. So I'm going to go from the very bottom to the very top of my y-axis. Remember, range is all of the y values. And then I'm going to start again with my smallest y value. So I can see here that my smallest y value is -2. And it's included because it's a closed dot. And then I go all the way up to my biggest y value, which is +4. And to write that as an inequality, I'm going to say -2, and then a 4 on the right. This one I'm going to use a y because the range describes the y values, and they are both less than or equal to. Now I need to test to see if this is in fact a function. So remember, when we have the graph, we use that vertical line test. So I take my vertical line and I run it across my graph, and as long as it's only touching it one time at any point, it is a function. So you can see that this graph is a function, so I'm going to circle yes. Okay, let's try the second one. Let's start with our domain. So I can see on my x-axis, the farthest to the left is right here, and the farthest to the right is right here. So that smallest number occurs at -3. So I'm going to do a -3. I'm going to do a bracket because it's a closed dot at -3. My largest number is right here, and that's +1. And I'm going to do a parenthesis because it's an open circle. If I were doing inequality notation, I will do -3. I'll put a 1 here. My x is in the middle. This one is less than or equal to, and this one is just less than. Anytime it's included, we say less than or equal to. Anytime it's not included, we'll just say less than. Now let's do our range. So our range, remember, is all the y values. So here's the lowest to the highest on my y-axis. So the lowest number here is -3. And you can see that since I have an open circle, I do a parenthesis because it's not included. My highest number occurs at 2, and I'm going to do a bracket because it is included. And so that will be -3 and a 2, less than or equal to a y, and then a less than here. Okay, now I need to test if it's a function. So I take my vertical line, and I can see that it does pass the vertical line test. So yes, it is a function. Okay, let's try this one. Let's do our domain. So remember, we highlight all of the x values that work on our x-axis. So our graph goes from here. Now, this one's a little bit different. You'll see that we actually have an arrow at the end. Whenever you see an arrow, that means that our graph is going to keep going in this direction, which is really headed towards infinity. So if it's going to keep going over to the right forever and ever, we'll say it heads towards infinity. So we're still going to describe it the same way. We're going to start with our lowest value, which is -2. And -2 is included, so I use a bracket. And then my highest value, it's not a real actual value, it's going to be infinity, because it's just going to keep going this way forever and ever. We use a parenthesis always with infinity. Now, if I'm describing this with an inequality, it's all of the x values that are greater than or equal to -2. So here we only need one inequality because it's just going to the right forever. Now let's do our range. So I'm going to highlight all of the ranges that work. So here's my highest point, but you'll notice that this one just goes down and down and down forever. So that means when I think of the lowest possible point, I'm actually going to call that negative infinity. We always start on the left, or the lowest. So our lowest is negative infinity, and then that's going to keep going until it reaches this y value at 4. And 4 is included. Now, if I'm describing the range, it's all of the y values that are less than or equal to 4. So it's y is less than or equal to 4. Now, once again, my vertical line test, I run my vertical line across. It only crosses at one point, so this is a function. Okay, let's check out this next example. For our domain, farthest to the left is here. And then since there's an arrow, it means it's just going to keep going forever and ever and ever to the right, meaning it heads towards infinity. So my lowest x value, you can see, is here at -2, but it's not included because it has that open circle, so I'm going to use a parenthesis. And since it's going to keep going forever and ever and ever to the right, we say it heads towards infinity. Now, with an inequality, this is essentially all of the x values that are bigger than -2. So we say x is greater than -2, not including. Now for our y values, you can see our smallest point is here, and then it's going to keep going up and up and up forever until it heads towards infinity. So let's start with our lowest point. Our lowest point is actually 0, and it's not included, and then it heads towards infinity. And these are all of the y values that are simply greater than 0, all of the y values that are bigger than 0. Once again, we can do our vertical line test. So you run your vertical line across, and this is a function. Okay, now let's look at this example. So here, I know it looks like a different type of graph, but we're still going to approach it the same way. We're still going to highlight all of the x values at work. So I see our graph goes all the way here, and then it looks like it might stop here, but notice that our graph actually continues on up until this point. So our lowest point is at -4, and it's included. And our farthest to the right point is actually at +4, and it's included. So if I write this as a compound inequality, it looks like this. Now for the range, the lowest point will be here, and it goes all the way up to here. So my lowest point is at -2. And my highest point is here at 3. Now this one, if you do the vertical line test, you'll notice something different. Even like right here, you'll see that my line is crossing my lightsaber at 2 separate points. So when that happens, so if you have something like this where your line crosses at more than one point, we know that it is not a function. And the reason, remember, is for this given input, there are 2 outputs. For this input, there are 2 outputs. And our main rule for functions is that for any given input, there's only one output. So this fails the vertical line test and is not a function. Okay, here's our last example. This one might look a little bit different. You'll notice it's just a vertical line. So we'll still approach it the same way. So if I look at the x values at work, it's actually just right here. So this domain is just actually a single point. So we can name this domain. This one's the only one that's a little bit different. Since it's a single point, we're going to use these fancy brackets, and it looks like this. So we're just going to say 2, because that's the only number. Or if you were just listing it, it is a discrete domain, so we just say 2. Either way is fine. For our range, this one does have a number of, or it actually has a set interval here. So our lowest point here goes up and up and up forever, so it heads towards positive infinity. And we'll describe it first with interval notation. So start with the lowest. That lowest point is at -4. So I use brackets because it's included, and it heads up until positive infinity. Now these are just all of the y values that are greater than or equal to -4. Now this one definitely fails the vertical line test because it actually is a vertical line. So this is definitely not a function. So we're going to say no. Okay, that is all for today's video. Thank you so much for watching.